All right, let's go ahead and get started. I do want to welcome you to the part two of Unit 0. We're going to be talking about conversions in this unit. Once again, if you would prefer to download these notes off of my outreach page, that's fine. The important thing is that you just have a good set of notes that you can work off to study for exams and quizzes and things like that. So here we go, conversions. I'm going to show you a technique called dimensional analysis that is the single most important way of converting from one unit to another. We're going to start though with one that I was taught in high school. I'm not going to stress it because of the fact that it does require that you memorize the mnemonic, and it's really not going to be very useful to you as you move up through chemistry and physics and engineering and things like that. But the important thing is that you'll know that there's a technique that you can use. It makes things a little easier, at least in the beginning. So here's how it works. So we're going to have to look at, for example, the various magnitudes of values. So we'll start with kilo. That means 1,000. So when you see kilo, that means 1,000 of something. Hecto is 100. Deca is 10. 1 or unit is 1. Deci is 1/10. Centi is 1/100th. And milli is 1/1000th of some value. Okay. And so now you're going to need to memorize this mnemonic. The least profane of the ones that I've heard over the years is this one right here. King Henry drinks only dark chocolate milk. So kilo, hecto, deca, 1, deci, centi, and milli. King Henry drinks only dark chocolate milk. All right? So how does it work? Well, the way that it works is this. If you want to convert, say, let's take, for example, 14.28 kilometers, and we want to convert that to centimeters, right? 14.28 kilometers is equal to how many centimeters? Well, we'll locate kilometers on this table. Kilometers, of course, is right here. Let me change to a different color here, make it a little bit more clear. There we go. We're gonna go from kilometers to centimeters. So where's kilometers? It's right here. And we're going to go to the right. We're going to go 1, 2, 3, 4, 5 places to the right, right? So when we write kilometers to centimeters, we're going to say the number that we've been given, which is in this case 14.28 times, now watch this, 10 to a power, and that power is, in this case, we went over 1, 2, 3, 4, 5, 10 to the 5th, just like that. So 14.28 kilometers is equal to 14.28 times 10 to the 5th centimeters, okay? Centimeters. Let's do another one. We've got 8,000 grams. Let's erase this to get this out of the way. Let's do 8,000 grams to kilograms. Well, grams is the unit, so we're right here. And we want to go to kilograms, so we're going this way. 1, 2, 3 places to the left to kilograms. So we're going to say, remember we went to the left, we're going to say 8,000 times 10 to the minus 3 kilograms. And that's it. And that's all I'm going to say about this technique, because again, this is not the technique that I prefer that you use. I want you to learn how to do dimensional analysis. All right? So here we go. Let's talk a little bit about how to do dimensional analysis. I'm just going to give you an introduction in this set of notes, and then we'll do some worksheets and so forth to help you get a better understanding. We're going to get a lot more practice, but for right now, I just want to show you the basic technique. So here's how it works. So we're going to start with 14.28 kilometers, right? I'm going to start with what I know. I'll write this over here because I want to do a couple of different examples. 14.28, and I like to put the number that I'm starting with. Let's write that a little bit neater. Here we go. 14.28 kilometers. And I like to put that over 1. That holds the place for me and makes sure that I know what's the numerator and what's the denominator. The next thing I'm going to do is this. I'm going to go from kilometers to the unit. Kilometers is on bottom. Remember, whatever unit's on upper left goes on lower right, and then the unit, meters, goes on top, right? So I'm going to ask myself, how many meters are there in a kilometer? The answer is 1,000, right? Kilo means 1,000. So there's 1,000 meters in a kilometer. If you don't know these, you need to study them, okay? So kilometers and kilometers are going to cancel away, and I'm going to be left with meters. But I'm not looking for meters, I'm looking for centimeters. So what I'm going to do is I'm going to keep going. So whatever unit's on the upper left goes on the lower right, meters goes right here, centimeters goes right there. How many centimeters are there in a meter? 100. Centimeters 100. There's 100 cents in a dollar. There's 100 years in a 100 years in a century. So 100 centimeters in a meter, just like that. And now meters and meters are going to cancel away, and I'm going to be left with centimeters. Now, final answer is going to be this. It's going to be the 14.28, just like that. 14.28 times 10 to the, this is how exponents work. I've got 3 zeros here, I've got 2 here. Just add them up. So this times 10 to the 5th power. Remember, that's what we got when we did it the other way, the mnemonic way, 14.28 times 10 to the 5th. Now, if we want to write that in scientific notation, scientific notation means I can have one and only one number to the left-hand side of the decimal. So I'm going to write that as 1.428 times 10 to the, now notice, I made this number 14.28 10 times smaller by moving the decimal to the left. So I have to make this number 10 times bigger. I do that by just adding 1 to 5. And I get 1.428 times 10 to the 6th. And that would be my final answer, okay? All right, that's called scientific notation when I have one and only one number to the left of the decimal. So that takes care of that first one. Let's erase that and try another one. All right, so here we go. Let's try this. Let's do 3,300 liters, and we want to get to decaliters, right? 3,300 liters, and we want to get to decaliters. So here's how we do it. We're going to start with what we know, which is 3,300 liters, just like that, over 1, times, now, I'm already at the unit. So the question is how many decaliters, and so whatever unit's on the upper left is on the lower right. And I'm looking for decaliters, so I'm going to say DAK. How many liters are there in a deciliter? There are 10 liters in a deciliter, in 1 deciliter. So now this liters and liters are going to cancel away, right? So they're in 1 deciliter, there's 10 liters. So now what I'm going to be left with is decaliters, right? So now what I'm going to do is I'm going to say 3,300 divided by 10. When I divide, I don't need a calculator for this. If I say 3,300 divided by 10, I just move the decimal place over to the left one time, and I get 330. So 330 then is the number of decaliters in 3,300 liters. And that's how I do dimensional analysis, okay? That's how I do dimensional analysis. Let's do one more. Here we go. Let's try this one. We've got 0.800. This is decagrams this time. So 0.800. That's decagrams. We'll put that over 1, just like that. And then what we're going to do is whatever's in the upper left-hand corner, we'll put in the lower right-hand corner. So DAG, just like that. We're going to go to the unit, which is grams. Now, how many grams are there in a decagram? 10. So I'm going to put a 10 right there and a 1 right there, just like that. So now decagrams and decagrams cancel away, and I'm left with grams. But I'm not looking for grams. I'm looking for milligrams. So I've got one more step. So I'm going to put whatever's in the upper left-hand corner goes in the lower right-hand corner. We have grams here. We have milligrams here. So how many milligrams are there in a gram? There's 1,000 milligrams per gram. So grams and grams are going to cancel away, and I'm going to be left with milligrams. That's the unit I want. So now what I'm going to do is I'm going to say 0.800 times, let's add up zeros here, 1 here, 1, 2, 3 here, times 10 to the 4th. And so what I get is 0.800 times 10 to the 4th. Now, if I want to put that in scientific notation, what I'm going to do is I'm going to move the decimal over to the right 1, and I get 8.00. Now, notice by moving it to the right 1 time, I've made this number bigger, this part of the number bigger by a factor of 10. So I have to compensate by making this smaller by a factor of 10. It becomes 8.00 times 10 to the third, and that's milligrams, right? And that'll do it for this one. See you on the next one. Thanks. Bye-bye.